and 28, so I'm starting with 27 and 28 today.
Okay.
And then we'll continue with if you have more requests, okay?
There you go.
So, finding zeros of a function question. Again, what is a zero mean is you find some numbers for x, enter them, and that turns the whole entire function into zero. So when I say find zero, most people think, oh, x equals zero, that's what we are looking for. No. We are trying to make the left side zero by entering, by finding suitable x values that can turn the entire thing into zero, okay? And they helped us a little bit. They have given that when you enter x equal 1, it already makes the function zero. So you have already one fish in the pocket or in your hand. You need to capture the other two more, at most two more. How do I know it's two more? Because it's a cube equation. You can have as many as 3 zeros. You already have one. Oh, it's x equal minus 1, by the way. How do I get the other two? Okay? So let me relate this question into this one. Let's say 84. And I'm telling you to factor this, factor it, and I'm giving you one of the factors is, let's say, 12. How would you find the other factor? How would you find the other factor? Right. Divide 84 for what? With what?
12.
With 12, right. Yes. So you use, this is like what's given to you. You divide 84 by 12. And you get the missing piece that way. So zeros work the same way. Because once you know a zero, that means this function can be split into factors using those zeros. So this four-term polynomial has already been given one piece here using this. What is that piece though? Can you write up? If it's x equal minus 1 is the zero, what is that piece here? It has x. Anyone? If x equal minus 1 is 0, one of the factors of this polynomial is x minus 1? Plus 1. It's the opposite. How do I know this is a factor? Look. Because 0 means when I enter this quantity, it needs to make entire thing 0. Look what happens. If I enter minus 1 here, add 1, it turns this thing to 0. And 0 times, no matter what you have, everything will become 0. Okay? So this is how you use the given 0 to make a factor out of it. Okay? Now, this is gone. This is used up. We always take the opposite of this number and find it here. Question is, how do I find this big piece? Because the other two fish is swimming in this pool. We are going to catch the other two. You already have one caught. Again, as you did on this question, we need to divide this polynomial with this so I can get the green zone. Okay? So let's divide. What's the most efficient, fast way of dividing 3x cubed, 16x squared, blah, 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 with x plus 1? There are two methods. One is long division, the other one is? Synthetic. Synthetic is the fast one, right?
Yeah.
Okay. So you set up something like this, remember?
Yep.
You put the divisor right here. So what do I put here? -1. Correct? So we put the -1 or opposite of this number here, or the original 0 here, whatever you call this, the same or opposite of this. And what comes here is just the coefficients. 3, 16, -17, and 30. And you put the horizontal line, bring the first one down, correct? And multiply, put it next. Add, multiply, put it next line. Add, multiply, put it in the next spot. Okay? So minus 1 times 3 is minus 3. This makes 13. Minus 1 times 13 is minus 13. This makes minus 30. Minus 1 times minus 30 is positive 30. Total is 0. Okay, I'm relieved to see 0. Why? If you get a non-zero item here, this is remainder, by the way. That means you did something wrong. If you get non-zero. I got 0, so I know I'm on the right path. Because I know this guy divides it, so I must be getting 0 reminder if it's fully divisible. Okay? Now, the question is, by looking at this, can you fill in the spot we are looking for now? What is that spot? How do you write 3, 14, and minus 30? I'm sorry, 3, 13, and minus 30? Becomes what? Minus 30x, x squared, x cubed? Is that how you write it?
3x squared.
Yes. You start with constant actually from tail to the head, and then you put x each time. 13x, and you put one more x, that's 3x squared. This is positive, so we add. This is negative, so we subtract. Alright, so the other two fishes, zeros, are hiding in this pool. How do I get them exposed? You need to just, this is a square quadratic equation. If you successfully break this down to two pieces and set each one to 0, you'll get the other two zeros. Well, can you factor this manually by hand? Maybe you can. Give it a shot. Can you? How does 3x break? I think it's 3x and x. How do you break 30? So outside and inside terms, when they multiply and add up, they must match 13x.
Oh,
10, 3.
positive 10 and negative 3.
We can try. You can try 10 and negative 3.
No.
Well, when I multiply outside and inside terms and add, it must be 13. 3 times 3 is minus 9.
15 and 2.
10 and x, 1. Wrong.
It's 15 and 2.
Hmm?
15 and 2.
15 and 2. Looks like we're here all day.
Just got it wrong.
15 and minus 2. One of them should be minus, so you can multiply minus, right? Is that right? Okay. Okay, minus 6x. This is 15x. Add these up. Do you get 13? Nope. Wrong pair again, Walter. Wanna try again?
Negative 6 and
Yeah. Negative 6 and
5.
5. Let's try that. I like that idea better. Negative 6 and 5. Which one is 5? Which one is negative 6? Like that?
Yeah.
Okay. That's minus 18x. This is 5x. Total is negative 13. It's wrong. So signs should be flipped. If you get the opposite of this one, just flip the signs. So it's an easy fix. Flip these signs. Was it over here?
That was
This one plus, this one minus, right? So plus and minus. Now exact match. Good, we did it. Alright. So can I clear this intermediate work? And we're almost there. All you need to do is now set these into 0 and solve to get zeros. So this is x equals 5/3. This is x equals minus 6. Just take opposite if you wish. But this one needs to be solved. Alright, if you don't like factoring, let's say you tried all day and couldn't get this pair. How would you get these two resolved alternatively, another method? from here to here, these two. There is a formula for that, remember? Quadratic formula. Do quadratic formula minus b plus minus square root b square minus 4ac over 2a, and you will get directly these two answers from this, if you like that. But yeah, it's not easy work. A lot of squaring and multiplying, square rooting, simplifying. You need to bring it down to here. So it's not easier than guessing these two numbers. Okay? Any questions? So we got all three zeros, and now we need to factor them. Oh, they didn't want the zeros actually. They just wanted to factor form. We did it, right? So they want this and that. This part exactly plus that part. Oh, if you do quadratic formula, you will skip from here to there. You won't get this, so you need to flip this back to here somehow. So I don't know how you guys can do that. Okay. I mean, you can do it, but x minus 5 and x plus 6. Okay, the solution set you the zeros. They are asking for the zeros now, 5 over 3 and minus 6. Okay. Any questions on this one? We're just using the one of the given zeros as a bait to use to guess the other part, find out the other part and factor it down more. Okay, there is a graph given. What statement are we trying to complete here? We are looking at when x values become huge negative numbers, x becoming huge negative numbers, what is y values happening? What y values happening? Again, x becoming negative huge means here's your x-axis. Where are the huge values listed? On the far left side on this way. Far left. Not even here. This is just minus 7, small number. Okay, imagine you're going really for farthest point on the left you can go. Where is y values approaching to? What value it's approaching? This says approaching to. You don't have to exactly hit that. You just need to converge to that. Negative 2. So this question is actually just, you can do it on the screen. You don't have to do any kind of math. So you see this arrow is getting closer to y equal negative 2 value. That's the level. Oh, this one is different. This time you're not getting any huge values. You're approaching to minus 1 value. This little minus means though from the left side. So you need to spot minus 1 on x-axis. Here they already put a dashed line there, thank you. So I'm on the left side of that and approaching. Look, do you see the dot approaching towards it? So you're coming from left and approaching to it. Where is your line above that approach going towards? Where is it going to? On the left side of minus 1. Maybe this one needs some coloring. Okay, here is my approaching move to minus 1. There is minus 1 right here, so I'm approaching. 1, 2, 3, 4. I'm taking 4 steps from left towards minus 1. And this one corresponds to this value. This one corresponds to this value. This one corresponds to this value. And this one corresponds to this. Where is these arrows marching to? Where are they going? Are they going like to minus 2 and staying over there? No. These are negative? No, you're looking at y values. When you say negative 1, here is negative 1. Y negative 1 is this value. You're saying that these green values are approaching to this horizontal line. No, they are past beyond that horizontal line. They are going to moving up and up, moving up and up. They are not approaching anything. They are actually going to infinity. Just measure how high these are at each step. 10, 100, 1 million, 1 billion, okay? So they are going up and up. Here, they are not going up, look. They are all lining up at this level. They can never go below this. So they are getting towards -2. Here, they are jumping into infinity. On the left of -1, you are at infinity. Okay? How about the right side this time? Now picture yourself to the right of -1 here. 1, 2, 3, 4 steps. Where is the image of each mark? This has image here, this has image there, this has further south, and this is deep down on the graph. Negative infinity, you're sinking. Alright, 4. This means far right side of x-axis. On the far right side, let's mark if you wish. Here is x, far on this side. And let's mark its image. This guy has this guy has that, this one here, this one there. So where is these arrows marching towards the? Still -2. What is this -2 called that? It's called horizontal asymptote because your line curve is approaching to it. Okay. Is this graph increasing or decreasing over an interval? First answer this. Is this graph increasing over an interval? Increase. Increase means you imagine yourself walking on this path. You must be climbing from west to east direction. Are you climbing when you go from west to east? Let's see. This is you. Am I climbing? Am I getting higher and higher up? That means increase. I'm getting increase, right? Oh, how about here? I disappear here and then pop up again from the bottom, and I'm climbing this hill, still climbing. So I'm always climbing this graph, never ever decreasing, right? Except one moment though. The moment I disappear, when do I disappear? At -1. At this moment, I'm out of picture and come back again momentarily, right? At -1, you're gone, poof. So you need to exclude that. So first, yes, it's increasing sometimes, but never decreasing. I think they're gonna ask where. Yes, it's increasing all the time from negative infinity to almost all the time except -1. So you guys need to exclude that by taking a hole there. Like splitting your interval into 2 pieces. Negative infinity to the -1, and you're taking a break at -1 and continuing afterwards. Alright, domain. What's the domain of this function? Just smash me to x-axis, all this picture x-axis. Smash from top and bottom. Negative infinity to positive infinity? Alright, one minor difference though. How about this dashed line here, right in the middle?
Negative infinity to -2.
Yeah. There is no point falling to this location because your curve never hits this, right? This moment is void. So it is
negative infinity to negative 1u,
mhm,
negative 1, 2.
same interval as in this one. This one.
Mm-hmm.
I wish we had a copy option. Oh. That's negative 1. Okay. What is next? Range. What is the range of this function? This time you smash from sideways. Compress this with 2 metal plates, push it and smash it to y-axis from left and right. Negative infinity to infinity, entire y-axis is covered, right? No? Except a hole here, right? Except this moment that is negative 2, everywhere else is included, so you need to exclude that. Negative infinity, negative 2. Alright, what is next? Vertical asymptote. Whenever your function goes all the way up in the middle of the screen at the moment and you disappear there, that line is called the vertical asymptote, and this line is 1, which is, what is the equation of this line? Negative 1, well, how do we type it? X equal negative 1. So they already put x, so we have negative 1. Alright, horizontal line, whenever your curve gets really converging into a horizontal line on the far left and far right, that line is your horizontal line, y equals negative 2, parentheses, the horizontal line. Okay, that's 27 and 28. Okay, which question do we go next? What's that?
34.
34. Okay. Use transformations of the graph of y equals 5 to the x to graph the given function. So that means you guys need to start with graph of this thing first. This function. Well, do you recall graph of exponential functions? Any base raised to the x, they always have either one of these two shapes. You either go up or you either go down. Which one is the case in this case? Upward going one? Well, how did you know that? Because what? Why did you pick up? Because the number on the base is positive. Is that the answer? Not positiveness. It's more than 1. Criteria is more than 1. If this is more than 1, it's an increasing curve. If it is less than 1, like 0.5, 0.3, or 1/2, 1/5, those are all less than 1. It's a decreasing graph, okay? So I will delete the other option then. We have 5 to the x. Again, the bigger the number, the steeper the angle is. So I think it's gonna be faster than this. I'm going to make much more, but this point is always fixed. No matter how huge this number is, it's always visiting 1 and then increasing quickly and decreasing fast as well on this side, going down on that side. This is 5 to the x. Question is, how do I make the picture of this one using the blue curve? You see, they are so similar. They have this part the same. Somebody added a number to x, x values kinda shifted, and somebody added a number to the entire function. There are two shifts here. It's left 2, yes, positive number added to x means left 2, and this up 1. So pretty much this is what you need to do. This was at 0, 1, right? So when I shift this 2 left, here's 1, 2, and 1 up, you're done. It's gonna be at -2, 2. -2, 2 is the new location of this picture. All you need to do is, let's clean this one up. I hope I can still choose this. Move this guy right here. Move that guy right there. All done. You see? Left 2, 1 up. Okay, I just want to test something quick though. You see, this is now not converging into 0 anymore. It's converging to some new place. Can you tell me the equation of this line, new horizontal asymptote it has? It used to be y equals 0 in old times. Now it has a brand new asymptote. What is it?
1.
1. It's speaking right here, right? It's 1. Yeah, that's it, I think. I don't know what else they want. We'll figure it out, okay? So 34. Oh, they want us to graph this one. I just did it quickly by entering values such as this is gonna be 1/25. How do I know it's 1/25? How do I magically put in these? They want us to fill out this table and graph it. Everybody knows 5 squared is 25, right? This is a no-brainer because I put 2 on top of 5 is 25. I put 1, 5. How did it become 1/25? It's negative. Okay. 5 to the -2 is actually 1/5 squared. Right? You turn into positive and make this 1/25. If you write this in decimal, it says incorrect. Be careful. Some people just put this into calculator. Oh, I can compute this by a calculator, but calculator will give you the decimal value 0.04. And when you put this into Connect Math, somehow it says incorrect. Although it's correct, it doesn't like decimal. It wants a fraction like 1/25. Okay? It liked mine because mine was all in fractions. Alright, now using these dots, you need to make the blue picture and then shift it to 2 left, 1 up. Which one is the correct shift? There are how many options? 4? Is it what? B?
D.
D. Okay. Yeah, seems like this one is the right option. -2, 1, converging into y equal 1, yes. Okay, next question. Oh, it's not done. Write the domain and range in interval notation. They want us to find that domain and range. Can you tell me the domain? Compress this, push this down and tell me the range. I believe we're going to come from here and it's going to stop somewhere here, right? This is our domain. Is that right? No, it's incorrect. Because although this looks like cutoff here, this line goes right all the time. It goes to the right. So this never ends going right. It keeps going right because this will go right and right and right all the time. So what is the domain then? Whole real line negative infinity to infinity. How about the range? Range is not so easy. Laura? Negative what? Negative 1 or no, positive 1, right? So positive 1 and up above, right? So it's how about inclusion or exclusion? Shall we use a bracket or parentheses? Can we ever touch 1? No, it's converging, getting closer but never touching. So we exclude 1, go infinity. Alright, and the last one, does this thing have a horizontal asymptote? Does it look like it's approaching to a horizontal line on the far left or right? Already mentioned that. Does it converge into a horizontal line? Yes, that green line is still on the picture, right? It's y equal 1. Doesn't have to be both sided. One side is enough. On the left it's approaching, so we're good. And that should be in y equal 1. Okay, this one is over. Next question.
About 54.
Oh, come on, we've done this many times. I don't want to do it again. No. No, I refuse, respectively.
How about easy one? How about
It's
38?
just computing, I mean, it's just punching the numbers into calculator.
Yeah. How about 38? That's the easy
38.
one.
Yeah.
We're doing a simple one.
No.
We're doing the easy one.
Come on. Can you go mid-level? Do you know how to change this into logarithm?
Yes.
Yeah, you flip base to base, free guy goes to prison and prison guy.
I really don't. I don't have.
Do you wanna? I can just type it.
Are
So
we done for
log
today?
base 2 of 4 equals 2. Good, I got it.
See, that wasn't so hard.
I can't
Can
tell
we
if you're
definitely
being
do it?
sarcastic now or not.
You guys are working on these, right?
Yeah.
On everything.
Yeah, pretty. Yeah.
50? What's yours?
When's it all finished?
The day before the exam, so it's Monday. Okay. 50. Next one. How do you solve this exponential equation? Alright, you see x is on the top. We need to bring them down. So these towers must be, these 3 and 7 must be cancelled out by a magic weapon, which is logarithm. But what phase are you gonna choose? Since you have two different phases, they don't match. You can either pick 3, 7, or something else, like ln. I like ln idea better because calculators can compute ln, even basic ones have that button. So choose ln of both sides. That's it. Put ln to both sides. And what will happen is these guys will go in front. And we will have 5x plus 8 in front times ln 3, 4x times ln 7. Again, don't rush into computing these guys. If you compute early, you round off early, and those rounding and rounding will combine into worse rounding and we may not get the exact correctness they desire for decimal place. May say incorrect, so wait until the last moment to compute them collectively. So what do I do next? This is just like a number. 4ln7 is together with a number like 6. This is like 6x. You have 5x plus 8 multiplied by another number. So I think we need to bring x's together to solve them, right? I will move this guy entirely to the left. And when solving equations, we don't like seeing parentheses, and I will multiply these two as well. So 5 ln 3 many x's, so I combine them. 5 ln 3 x plus 8 ln 3. This is completely a number without any variable. And this guy, can I move these guys? Can I squeeze this ln 7 between these two? They're replaceable. It looks just nicer this way. 4 ln 7 and then x. I'm moving these two, okay? And all together this thing is 0. Okay? Look. I have several x's here, several more x's subtracted. So just like you have 5 apples, 4 apples, you combine to 1 apple, you just operate on the numbers in front. We will combine these the same way. They will collect into 1x with subtracting these two numbers, 5 ln 3 minus 4 ln 7. Okay, what do I do with the number? This has no x, so I will send it to the other side as minus 8 ln 3. The final move, you need to get x by self. By the way, can I subtract this? 5 minus 4 and ln 3, ln 7? No. They're not like, if this was ln 7, you could. 5 ln 7, 4 ln 7 makes 1 ln 7. But like right now, they don't. So I will just divide both sides, this entire stuff, so that x can be alone. Okay? You're all set. Your x value you're looking for is this combination of numbers. I think they are expecting both exact and approximate answers, part 1 and part 2, or just approximate answer.
Are they
Write the solution in exact values. This is the exact value. No rounding. So that's what we need to enter here. It's messy. Did I get anything wrong? Tell me before it's too late. Sometimes you stupid mistakes too. Seems correct? Yeah. Okay, now we need to take this into Google and ask Google what this thing is, or you can tell me. You wouldn't? Alright, first set up your fraction, and then that top was minus 8 ln 3. The bottom was 5 ln 3 minus 4 ln 3.
Or LN7, I think.
Oh, yeah. Thank you. Wouldn't be that good answer then, yeah. Up to 4 digits means take the 5th digit and round up. So this is gonna be 0, and this is gonna be 7. 3, 8, 3, 7, right? Perfect. That was 50. Any questions? All right. If you still have any questions, work tonight.